now. Yeah, good evening, students. Today's session will start by 7:20. Okay. Uh, Please don't leave the session. Sir will join by 7:20. Just now he informed me. Okay. Good evening, sir. Welcome to the session.
Yeah, hello. Yeah, hello. Can you give me host man? Yeah.
Yes, sir. We can hear you, sir.
Yeah. Fine. Already given. Fine. Thank you very much. So, good evening, students, and as part of the continuation of the files, we'll see what are the pending topics, and then after completion, we'll move ahead with the new topic called pre-process directives.
Sir, sorry to disturb you. Your voice is little low, sir.
Yeah. Fine. Yeah. So, is this my voice is audible now?
No, sir. No difference.
Hello. Still
Yes, sir.
voice.
Yes, sir. Audible,
Yeah.
sir.
Yeah. Fine.
Yes, sir.
Yeah. Thank you. And so we are going to continue with the previous topic. Some of the topics are left in the files. After that, we'll move ahead with the pre-process directives and as well as the command line argument. These are the topics ending in the C programming. Okay. So my dear students, and let us move forward with this pending topic. So in the last session, we have discussed about file functions like fputC and fgetC, like the character by character. How can we write into the files and reading data from the files, and then followed by the fputs and fgets. How can we read the string by string and as well as the display into the files? Okay, and also any kind of data types like employee details, employee number, employee name, salary, any different kinds of data. How can we write to the file and how can we read from the file and display to the monitor? We have discussed. Now, the next one is the fseek function. Okay, let us move with the fseek function. Now, up to fprintf we have completed. Yeah. So, what is the syntax of the fseek and what is the purpose of the fseek function? Okay. So, the fseek function is used to set the file pointer to the specified position. Okay, in the specific position you want to move your file pointer, you can do. It is used to write data into file at a desired location. That means from the specific position to you want to write something data into the file, you can do that. That means a portion of the file you can take and you can put into that. Okay, so if you look into this syntax, you should see fseek of the file pointer, like whatever the file you are pointing to your variable, that file pointer, and the offset, that is called displacement. That means the location where you want, okay, where you want to point your location, your pointer, in which position you want to point. The third argument indicates that there are some predefined result words. Okay, we are using as part of the third argument, that is seek set, seek cursor, seek end. That means, see, even in your word or anywhere, okay, while you are searching, it will search, it will ask, like, you have option called find and replace. In that find and replace, your cursor is at particular location in between. You want to look into entire the file, or from the cursor position to top, or from the cursor position to the rest of the things. Okay, like that you need to specify, right? Similarly here also, okay, you need to specify entire the end of the file you want to see, or with your current cursor position and all. So here by default we are going to use seek set position. And if you see this example, okay, I'm going to show you. I'll create one file that is called myfile.txt. Myfile.txt. We opened with the write plus mode. Why I said write plus mode? Okay, I'm going to write some data to the particular file pointer. Now you tell me, I just created a file pointer FP. I just created a file pointer FP. I opened a particular file, myfile.txt. That means if the file is not available, it will be open in the write mode. Now, using foots, you can go for, foots, foots, or fprintf, whatever it may be, right? But I want to write one small example for understanding of the fseek. That's why I just kept one string. This is Blackbuck. Okay, that string is writing to the file pointer. Now, what is there in the file? This is Blackbuck. The content is there in the file myfile.txt, right? Yeah. Now, in this, what do you want to do now? What is your required operation? Now, my requirement is, okay, in some specific position, I want to add some text. From this specific position, I want to add my text. From where you want to add? Say, for example, 1, 2, 3, 4, 5, 6, 7. Okay. This is, after this is, I want insert my text, that is EV ready. I want to insert, let's assume. Okay. So that's why I'm using, okay, my file pointer is pointed to at 7th location. Okay. My file pointer is located at the 7th position. So my file pointer FP, that is located in the 7th position. 6 set is the result word, right? Then I'll put fput as EV ready. That means in this file position, I return to the FP, right? In the particular file. Where is my file pointer? See, by default here, if I write the right here, by default, when you open the file pointer, it is located in the starting location. Now, I just moved my file pointer to the 7th location, and I just added something. After that, you see what is the content will be there. Let us run this. That means if you want to put your content in the specific position, you can use fseek. Fine. Let us create a new file and let us run this. I'm going to give you the example of example program on fseek function. Let's see about the fseek. File pointer fp. Sorry. stdio.h. Then fp equal to fopen. So you create any file, like in that particular directory, I will open my file.txt. I can do the write plus mode, so that I want to write append also, right? Okay, that's why I use w plus, that I can append. Okay, otherwise what will happen if I use only w? When you write the new thing, only new content will be there. It will not be there existed content. You want to append with both, then you can use w plus. So I can go with fput s. I want to write something, right? So this is Blackbuck, comma fp. I just written like this, and then now I'll use my function fseek. By default, your file pointer is pointed to the ending, right? After writing. Now I'll keep this in the particular location, either 7th or 8th location. So not a big issue. And then I'll write seek set is the keyword. After that, I want to put some another text, fput s, anything like ready, comma, in the particular file pointer. And then I will close this. My file pointer was closed. I'll save fseek.c. Yeah, now let me run this program. Yeah, I just executed, nothing was displayed. Why? Because this file should be created, and what is there in that, we'll see. I'm going to open my E drive. I will open my E drive. See, a file was created. My file is created. I just open my file. Okay, see what happened. This is Blackbuck earlier. Now in the 8th position. Okay, here 4, 5, 6, 7. After that space in the 8th position, EV Reddy I have inserted, right? So how it was happened? So before writing this EV Reddy text, I kept my file pointer location at 8th position. That's why after that, whatever the data you have given, it is there. After that, the remaining rest of the content is displayed. Okay, some content is there already. Those data is displayed here. So likewise, you can place wherever you want in the particular file pointer. That is with help of the fseek. Okay, so now let us move to the next function, that is ftell. So the ftell function returns the current file position of the specified stream. We can use this ftell function to get the total size of the file after moving file pointer to the end of the file. Generally, when we can use, you want to know what is the total size of the file. Then what you will do, you will move your file pointer to the end, like by using constant called seek end. Okay, we can use seek cursor, seek set, seek end. In this example, I'm going to use my seek end predefined constant to move the file pointer at the end of the file. So by using this constant, previously we have used seek set. Okay, that means that particular location it will be set. You want to move your file pointer to the ending, where I'm using seek end. Okay, so with help of the fseek, you should move your file pointer to the seek end. After that, you need to ask by writing ftell. Okay, so that it will give you your position, so that that is indicating that the total length is going to be displayed. Okay, so I'll show you this example program. So in this example, you can understand, I just created a file pointer. I have opened a file.txt. That means if you want to check what is our aim now, I want to find the total size of the particular file. That means what? The file should be there. It has some content. Then only you can find the length of the file, right? So assume that a file is already available having some content. Now you tell me, how can I open? Can I write the data into that, or can I read the data? We should read the data, right? That is the why. While opening, what is the mode I should use? Read mode. You are not writing the new content, right? You are just read something data from the file. Okay, fine. Then that's why I'm using read mode. Now, then you keep your file pointer at the end of the location. Okay, you keep your file pointer at the end of the location. That's why I'm using fp, 0, seek end. Yeah, after that, you just ftell function returns the end of the current location. Current location is already you kept it ending, so that gives current location. Okay, that means the length itself, that internally indicates that length of that. So that value is going to be stored in the length. Okay, simply you can print it length. Then you can understand the number of bytes. Okay, total number of bytes of the particular file. Okay, after that I closed it. See, let's see. let's see whether we have the file 1 is there, right? Any file. Yeah, we have some file 1. I will open the file 1 with read mode, right? I will open file 1 with read mode. I'm going to create new file. Example on FTL. In the next class, my dears, I'm going to tell you, this is very important one, why I should use hash include stdio.h, hash include string.h, hash include conio.h. Can I do like this? Hash include blackbuck.h, blackbuck.h, we can do. Okay, hash include blackbuck.h or hash include ravi.h, some name, gagan.h, hash include gagan.h, something you can give any name. Okay, why you have to give this one in the double quotes, that I will tell you. Okay, so what is there in this header file? What is there in the stdio.h header file? Like your printf and scanf. Similarly, in string.h, how we have str cpy, str concatenation, length, okay, concatenation, comparisons, and all the functions. Similarly, you create your own functions and you kept in the file header file and you include and use in this program. That is the next topic. After completing this, I'll tell you how to create user-defined header files also. Okay, fine. Just after completing this FC capital and rewind, then I'll explain with this as part of the pre-process directive. Now, int main. So in this example, to display the length of the file, example on FTL, to display length of the file. Yes, what is going to be that length? I'm going to print in this variable length, right? Yeah, fp equal to, I should open it, f open. What is our file name? Equivalent something file1.txt. That is our file, right? So shall I open in the write mode or read mode? You need to do read mode. Why? Because you are going to read the data from the file. You are not writing any data to find the length. Then using fseek, you should keep your particular position, your file pointer in the end of the location. Okay, fp comma 0 comma seek underscore end. That's why your file pointer you kept in the ending position. Now your ends, okay, your file position is there in the ending position. Okay, ftell function will return the current pointer, right? Current position. That means it indicates that your number of positions. It returns where you are going to store in the variable. What is your variable? I took length. You have one variable, right? It returns the length of this variable. I kept in this integer variable. I'm going to print that value. Okay. After that, I'll close my file pointer. So now you want to print your length. The value is there in the variable length. Printf size of the file percentage the bytes, right? How many number of bytes you have? Length. Now that's it. I'll save this. What is this? ftell, right? ftell.c. Now let me run this. Yeah. See, you got size of the file 27 bytes. Let us check it. Let us check it. I just open file 1, 2, 3, up to 27 calculation is difficult, right? It will take time. Now what we will do, this also more, file 3 also. Okay, let's see. I will keep, otherwise in the file 1, I'll put only welcome to. Now you tell me how many characters we have. 1, 2, 3, 4, 5, 6, 7, 8, space 9, 10. Okay, up to 10 bytes should be there, right? Fine. Let's see. I'll save this. I will save this so that it is easy for you. That output you should compare, right? With known output, if you compare, it is good for you so that your program gives correct, accurate result. You can understand. Now let me run this program. See, size of the file is 10 bytes. Is that correct or not? Okay, the total is 10 characters, right? 10 bytes. That's it. Okay, so this is the way we can get the file pointer in the ending position. After that, with help of the FTL, you can display the current location. That is nothing but it is the total length of the file you can calculate. That's very simple. Now let's move to the next topic. Rewind. Okay, rewind. Name itself it indicates, right? Rewind is nothing but already your file pointer is there in the ending. You want to keep it as the starting position. Okay, so the rewind function sets your file pointer at the beginning of the stream. Okay, file stream. That's why we are calling it as a stream. Okay, it is useful if you have to use the stream many times. Okay, so number of times you want to move your wherever your pointer is located, simply you can keep in the starting of the file. That's why I can use rewind. Okay, so with help of this, when we can use this kind of rewind function. Okay, see, what is this example? Yeah, so you take any file and read character by character, and until end of the file you read and you display. Okay, so you try to understand what happened here. Simply, okay, you just open the read mode and you have written. Okay, this is already we did the program, right? Character by character reading and see end of the file. Yeah, and see end of the file and display it. So one time you read and display. Fine. Now, after completing this, where is your file pointer? Tell me. After completing this reading character by character, that means you have end of the file welcome to is there, and everything is reading. Your current position is what? End of the file is your current position, right? After reading everything, whenever you are reached to the end of the file, you are coming out, right? Yes. Now your file pointer is end of the position. After that, I just kept again rewind of the FP. Now it is pointed to the starting. Again, you are going to display. That means what? Okay, you want to display 2 times. What is happening here? You want to display 2 times. So your file pointer is reading the content. After that, your pointer is coming to the end of the file. Again, you are keeping in the starting position, and again you read it and you display it. Okay. Yeah. That's why we kept. We are using rewind. This is a small example. Okay. Yeah. So let us run this. I think the rewind function is already kept here. File1.txt. So what happened here? You tell me. Simply, it will read the data and it display it 2 times, right? So that's why I kept my file pointer again starting. Again, I'm reading and printing. Okay, that's the reason it is going to be printed in 2 times. Let's see. Yeah, see here, welcome to, welcome to. Your content is there 2 times. Welcome to, welcome to. Okay, how it is possible? Your file pointer again moves to the starting position. Depends on this, you can do any kind of requirement. So I hope, as part of the, studying this files concepts, we have covered all the examples. I hope this is sufficient for you. Okay. So all functions, F get, CF put, CF get S, F put S, almost 6 and 9 functions we have used. These are all is used to work with file operations. With that input, you should do some kind of operations like I'll give you the assignment. Okay, I'll give you the assignment on the files. Okay, what is the assignment on the files? Assignment on the file. What you should do, what you did, how to create a file. Assume that file1.txt. You know how to create a file, right? You know how to write the data into the file. Okay, assume that welcome to Blackbuck engineering, something you are writing. Fine. So you know how to create a file, you know how to write the data into this file. Now, my requirement is you create a new file, copy the text, you create this file. Okay. That means you know how to create a file, how to write the file. Okay, completed. After that, you know how to read also. You know how to read from the file by opening read mode. But previously we have displayed to the monitor, that is reading the data from the file and displayed. Now I don't want read on the monitor. I want, instead of keeping display in the monitor, you just keep a copy of this read character by character or string by string, whatever you want to do it, and again you put into another file. Nothing but what happened? A copying of this content into this one. This is nothing but copy a content of one file to another file using file concepts in C. Okay. So my program is okay. Write a C program to copy content of one file. Otherwise, simply you can say copy content of file 1 to file 2. Okay. Copy content of file 1.txt into file 2.txt. In this case, you tell me, is this existed file or a new file? Assume that this is the existed file. The file is available, content is there. This should be, you create, it is empty file. You should create and copy this. That's it, right? That means source should be there, destination should not be there while copying. Okay, then you create it and you copy it. That is one thing. And the other one is copy. What is move? The source content is not there. Simply you have moved to the new file. That is called move. So copy and move. What is the difference of copy and move? Copy and move. What is the difference? In the examination, they'll ask both. Copy is nothing but source content is available and destination is also content is available. Whereas moving from here, you are moving to here, source content is not available. Okay. So like that, you should do both. Write a C program to copy content of file 1 into file 2, and another program is /move. You should do both. Move also. Okay, that is one thing. That is one program. And another program is And another program is, this is an application. Okay, this is an application. So earlier we did a student data, and displayed some student data like a student number, student name, okay, some kind of marks, total marks, and average marks. Okay, now what you should do, read a student data, student number 1, Gopal, marks so and so 78, and average something, total marks you put something 340, and something 80%, like that. Okay, you take multiple data. Okay, you take multiple data and you put into, okay, and you take multiple records of the student and you create a file called student.txt. Create a file called student.txt and put some student number, name, total average of 5 records. How many records? 5 records of the students you keep into the file. Okay, already I have shown employee data. Okay, likewise you create a student data and put something data and calculate total and average, and you keep those data into the file, so that the data should be there permanently. Okay, and you can do some kind of electricity bill. You create another file called electricity, another assignment. You create electricity bill.txt, a file which consists of, that means you create a file, this data should be there. You read it and you calculate it, you keep into that particular file. What is the thing you want to calculate? Consumer number, right? So what is the consumer ID, consumer name, and what is your present meter reading? Your previous meter reading. This is previous meter reading, current meter reading. Since both are present and previous, both comes with P. That's why I can say previous meter reading, current meter reading. Okay. Assume that at present we have 400. What is your previous meter reading? Is 200 units. Now what is your number of units? Total number of units consumed 200, right? 400 minus 200, it is 200. Based on that, you calculate how much amount you have to pay. Amount. Okay, assume that something 10 per, 1 rupee per unit, total amount is 1 rupee, like this, right? Amount. Simply I can say amount to be paid. So this data you create and you should store into electricity department. That means read the data, calculate, and put into the file. Same thing we have did with application. We have calculated everything, but we didn't kept into the file. Same program, you can use structures concept, you can use arrays concept, you can use pointers concept, you can use functions concept. Anything you calculate, finally the data whatever you have in the variables, those data keep into a particular file. This is possible as a part of your fprintf and fprintf function and fscanf. I told you fscanf, it is possible. You try to do this program. That means whatever you did it earlier, all the programs you can keep those resultant data into the file, so that result file will be there. Okay, so that is your assignment related to the files. Now let us move to the new topic, that is pre-processor directives. Yeah, pre-processor, working with C pre-processor directives. Yeah, what is pre-processor directive? Pre-processing, the name itself is saying that pre-processing, that means before processing. Before processing, who is processing? All your programs, who is processing? Tell me. Your compiler is processing, right? Whenever you write, for what purpose I'm using Control F9 or compile and run? To process your program. Are you clear? To process your program. That means the compiler should understand that what is your variables, what is your header file, what are the functions you have used, Okay, so are that functions are available in the particular header file or not? Like stdio.h, string.h you have used, but you have used in your program string copy. If you're not included, that your program says that your string.cat, like strcat function is not available. You have not included. Okay, that means that function is not identifying in your program where that function is written. Okay, so the compiler should understand, okay, the related code and what are the variables you have used, what are the data types you have used, what are the functions you have used. If you have used any function which that related function is available in that previous header files or not, each and everything will be checking during the compilation time. Okay, before that, if you define anything, that defined values going to be understood by the compiler. I'll give you example. Okay, that means C preprocessor is a microprocessor, and that's why we call it as macros. Microprocessor that is used by the compiler to transform your code before compilation. Okay, so it is called as microprocessor because it allows us to add macros. I'll show you what are the different types of macros are there. So whenever, how can we identify? Whenever you use hash indicates preprocessor directive. What is that? Hash is the preprocessor directives. So what are all the things we have as a preprocessor directives? Hash include. You are using predefined header files, stdio.h and string.h, math.h, stdlib.h, all the header files, whatever you are using. These are all compiler previously, before compiling, your program compiler can understand what are the things you are included in your program will be identified. What are all the things are identified? Okay, can we understand? So now I'm going to show you some of the preprocessor directives. Hash include, hash define. Okay, so I will define my variables entirely throughout the program. Okay, how can you define by your own? That we'll see one by one. Once if you define, you want to unclear the memory by using undefined, by using UNDF, if def, if ndef. We have a lot of preprocessor directives. Out of that, like hash if, else if, end if, error, pragma, these are all preprocessor directives are available. Out of that, we will define something so that you can understand the remaining topics. Okay. After that, I will show you. Okay. After that, I will show you user defined header files also. Okay. Now we will define. So now, what is a macro? Okay. So, and also we can call it as a macros. Okay. A macro is a segment of code which is replaced by the value of macro. A macro is defined by the has defined directive. Okay. This we call it as a macro. This is another name. Okay. These as defined directives we can use for two purposes. One is a variables declaration, that is like an object like macros. What is the object like macros? If you want to define a variable, see, throughout of your program, you want to define a constants also. People used to call it as a constants, like pi. So you know what is pi actually, but if you say pi value is 3.14, right? But your program doesn't know what is pi. So pi r square, you want to define pi r square. Yeah, 1 second. Yeah, you want to, while you are using pi r square, okay, and 2 pi r, something area of the circle, area of the, circumstances of the circle, 2 pi r, something you want to calculate. But readability purpose is pi r square. But what is pi? It has some value, right? But, I can't do that. Yeah, I'll tell you. Yeah, generally you want to calculate something pi r square. Okay, So generally, if I write like this, pi r into r. If I write like this, can you get output? No, right? In my program, what should I do? You should read r value. Otherwise, you give something r value is some 5. Okay. If I give you r value 5, if I say pi r square, is this understood by the program? What is pi? Is it any readability word? No. That is also you should read the value. Instead of that, it has some constant value, right? That's why what I will do, I will define as defined pi nothing but 3.1412 something is there. I will define. So this constant variable throughout of my program, this variable has some value 3.14. So whenever you use this is readability per you. Pi r square. I'll use like this only. What is this variable? It has some constant value. You can define constants. Okay. So when this value will be substituted, automatically 3.14 into 5 into 5, the result will be displayed like this. Okay. At the time I can use has defined. That means you want to define a particular variables with some constant value throughout of your program. Okay. This pi, when it has to substitute at the time before compilation, okay, while you are compiling, this value will be substituted so that it should not show any error, right? Fine. Yeah, that's why we are going to do this. And not only that, and I can do another one is hash include. Hash include. What happened here? When you write string.h, okay, whenever you write into your program, whenever you write something in your program of predefined functions, what is happening? Whenever you write strcat something, okay, so this system will identify, is this function have you written? Like, is the function is user-defined function or predefined function? Is it user-defined function or predefined function? That means what? Have you written in your same program like function called function? Have you written something like how you have written, say for example, you have written something add. You have written add. Okay. Yeah, you can define like this. Add. Say add of int a comma int b. Okay, something. And return of a plus b. You have written something. You have written something. You are returning this value and you stored into somewhere result equal to something. You can store and do display. Now my requirement is you have two types of functions. You have two types of function. This is library function. We call it as library function, or we can call it as predefined functions. Predefined functions, or we call it as built-in functions. All are same. We call it as built-in functions. Okay. Yeah. So that is already written by somebody else. This is your written add. So that's why this we call it as a user-defined functions. Fine. Now the compiler will check whenever you are using this function. Compiler will check at the time of compilation. Is this function is predefined function or user-defined function? If it is user-defined function, have you written this function? This is called a function definition. What we call function definition. Is this function definition is already available or not? If not, where it is available? So it will look into header file. It will look into header file. The control will move to the particular header file. It will check, have you, this function is defined there. So now if the function is defined in the file header file, the control move to the particular header file. Those code will be substituted here. That this much of process is happening inside when you compile. Okay, fine. And also I'll show you the same thing how it is happening. Okay. Now if you do like this, so this will look into any location wherever your path is there, wherever the particular strcat is there, it will look into that. So sometimes you can define your own. Assume that I'll create blackbuck.h or something.h. So what I will do as include, okay, with your own name, you want to create ravi.h. Okay, ravi.h. So this file will look into the current location. Wherever your particular directory are there, in the particular location, it will check all the related functions. Assume that a header function is available in this header file. So I don't want to write like this. Simply, I will use this include and I will access this. So your control will check into this header file that particular functions are available. You can see the output. Let's see. Okay, how we are going to include this. These are all pre-processor directives. At the time of compilation, it will see your particular code is available or not. Everything will be checked into that. So one of the pre-processed directive is somebody is asking no, I'll go with slowly, no issue. Now, one of the pre-processed directive is hash include. Okay, we are using, that is everybody knows hash include stdio.h, but I want to create my own. Let's see. Hash include pre-processed directive is used to paste the code of the given file into current file. Okay, it is used include system defined and user defined header files. Okay, system defined header file is stdio.h, stdlib.h, string.h, and user defined header file. If included file is not found, compiler shows the error. Okay, while I'm using the hash include, there are two types. I can use with the angle brackets. I can also use double quotes. What is the difference between these two? Okay, what is the difference between these two? If you use in the angle brackets, tells the compiler, okay, to link that particular file. Okay, look for the directory where the system header files are held. Okay, where the system header files are there, wherever the system header files are there, predefined, right? Internally, it will locate into the particular system header files location. It will check the particular header file is there or not. If you use in double quotes, tells the compiler to look into the current directory from where your program is running. Okay, that particular current directory it will check. Now, what I want to show to you, for better understanding of this, what I want to show you, I'll delete this one and I'll show you. Now, your task is here. You should create a new header file that is arithmetic. All arithmetic operations. What are the arithmetic operations? Add, subtraction purpose, multiplication purpose, division purpose. All arithmetic functions, like how the system they defined with string.h in the string related function, strlen, strcat, okay, strcmp, how we have did everything. Similarly, I want to create my own name. Okay, what is the name? If you give ravi.h, it is not good. If you want, you can give no issue, right? I want to create my own header file that is arithmetic. All the arithmetic operations are there in the arithmetic. Okay, .h. Is arithmetic.h header file is available? No, I want to create. Okay, which consists of head, all add, subtraction, multiplication, divisions are available. Okay, the function definition is available. Assume that what we did earlier. Okay, my program is stdio.h, like this. I used to write int main. We are going to write like this, right? Yeah. So read two numbers. Okay, int a equal to 10 comma b equal to 20. Okay, so how you are going to read, and you have something result equal to add of a comma b. Okay, so where is a comma b? 10 and 20, two values are stored in the variable. Okay, I'm passing as an argument. This add function will execute and will return, and it gives the resultant. So now I want to print it. Printf addition of a and b is simply I can say %d comma and then res. This is the my function, right? This is the my function program. Now, where the function definition should be there, generally we should write in the same program, right? Yeah. Instead of that, instead of writing here, I'll write here. This is the header file.h. Here I'll write. How I will write? So instead of writing all functions, I'll write one. The rest of the thing, you please write it. In this program, what I will do, this is another program, right? This is another program. This program is so user defined user defined function header files. Okay, custom header .c. This is my program. Custom header files.c is my program. Here I'm writing. Okay, so there is another header file. How can you implement this function definition? You tell me. So you are passing a comma b. So you should take a comma b, right? You can put x comma y. Okay, this is function definition. Since you are returning something, so I should return some value. How you are going to return? Return of x plus y simply. Otherwise, I can store into the result too. You can return that value. That's it. Return of x plus y. Okay. Fine. Now, if you are passing 10 comma 20, that 10 plus 20 will be returned, stored in the result. If you pass anything 5 comma 6 something, it will be written value. Fine. Now, this definition where you are written arithmetic.h. Same, similarly, str, length, concatenation, comparison. This code they are written in these header files. The code, whatever they written, somebody written by the Dennis Rich, they written in the header file.h. Similarly, I'm writing here. Now, is this add? If I use add, can I get this output? No. When you can get the output, you should include this arithmetic.h. You should include this. I want to include hash include. You want to look into your own location? Yes. Arithmetic.h. Why I written like this? Why I writing like this? So this file is there in my local position. That's why I'm including with double quotes, not writing in the C at the files. Okay, fine. This is C location. It will check it. So let us run this program. Then you will understand better understanding of this program. Now, how can you create header file? Same like instead of C, you can put H. I'm going to create a new file. Better I can copy, paste this entire program. Sometimes while you're copy pasting, it will show some errors also. Maybe double quotes errors. Yeah, let us see. So this is my, I'll put into particular directory into E drive. Yeah. Custom underscore custom.c. Okay. Simply I can say custom.c. Yeah. Now, this is my file, right? Yeah. Where is this header file? So, is there any code of this, my dear students? Try to understand. This add of a comma b, the execution, like, right? The definition of the function. I'm calling the function, but where is the function definition? Like passing these arguments and returning. This code should be there somewhere, right? Generally, I used to write in the outside of the main program. But now, instead of writing outside of the main program, I'll create another file. I'll put there, right? Arithmetic.h. So I'll create. But while creating header files, you should not give any main function. You should not give any main function. You should not give any main function. Main function should not be there. Okay. So now you save this. What is the file name? Arithmetic.h. I'll give you like this. So now I'm going to save this in the same location, arithmetic.h. The file name is the arithmetic.h. Okay. Arithmetic.h. Now you run this program. Now you run this program. Yeah. Let's see. Yes. See here, while I'm copying pasting, sometimes I'll get error also. See, I written arith.h int, okay, a comma b and return of a plus b. In this custom header, arith.h. Okay, simply I'm using a comma b, something, same result function. Okay. Now let us run this. Yeah, I got a result is 30. Result is 30. Okay. So similarly, you can use okay, in this header file, you can write any functions like number of functions you can define by your own. Okay, or a prime number or not, Armstrong number or not. Okay, square root, all the functions you define your own. Okay, you can add everything. You can run your return of a minus b like this. Okay, return of a minus b. Anything, any program, whatever you have learned, all the functions, you can do this. Fine. So this is called, how you are written, hash include in the single double quotes. This is the way we can define it. Now let us move to the next topic. Hash include. Next, hash define. So where we can define this hash define? Okay. So hash define preprocessor directive is used to define the constant or macro substitution. It can be used any basic data type. See, hash define token value. Hash define pi 3.15. If I print the pi value, simply %f comma pi pi. Directly, you'll get the 3.14. You can read R value and you can use pi R square. That you can do based on your requirement. Okay, based on your requirement, you can do this. See, simply I define as define pi constant 3.14. I'm just printing pi value. Okay, 3.14 will be printing. Okay, you can see this, just defining the constant and you will print the pi value. So this pi value will be printed. I'm giving the basic. Okay, once it is returning nothing but what you can do, simply you can read radius. Okay, you can read radius, R value. So you want to calculate something area of the circle, then you can say float area. Okay. And printf enter radius. That it's a small program, you should practice. Okay. Now generally you read radius value %d comma ampersand or read radius. Now you want to, once you know the radius, you can print the area of the circle. How you are going to print? Pi r square, right? Pi r square. Now can you do pi r square like this? Generally it is not possible, right? But now I defined pi value 3.14. If you're not giving like this, you should substitute 3.14, right? So that means what? With the fixed constant value, you define the variable so that it is readability. People will understand what is pi, as your, regular you are using pi r square, right? That's the reason you can define a constant value with the variables, right? At the time I'm using has defined, that's it. Okay, you print printf. What is that? Area of circle, right? Please %f comma area. That's it. Okay. Now, what else required? You need to read R and you are going to calculate it and display it. Fine, that's it. Now, yeah, I'll run this program. Enter the radius. I give the 3. You got radius is so and so. See, this is the area of the circle is so and so. This is previous value 3.14. It is printing, and you don't need to print this. So like this, you can use pi constant value. Okay. Once if you define, if you don't want, yeah. Now let me run this. Yeah, enter the radius 2. Yeah, area of the circle is 12.5600. You got it. Okay. Now, okay. Now you want to undefine. Okay, by using hash undef. Simply hash undef. You want to same thing, undefine the pi value. Okay, then it will throw error. What is pi? It won't understand, right? Pi undeclared. It won't understand pi. You should define. Otherwise, what you should do? Simply, you should put 3.14. You should substitute like this. Okay. Then you will get the output. Enter radius 2. I got the output. Okay. Likewise, you can define and undefine. Okay. With help of has defined and has undefined. Similarly, you can see the rest of the preprocessed directives. Okay, remaining all you can understand hash, if, else, and all. You're all familiar. Okay, with your if conditions, else conditions, everything you can define as a macros, as a macro. Okay, and not only for the variables, you can also define functions. You can also define functions. Minimum of a comma b, you define like this. And when you pass two values, if a is less than b, then it returns a value, otherwise it returns b value. Okay. When you are passing a function with 10, 20, okay, and 10 less than 20, condition true, so it returns a value. Okay. So finally, when you call the function, it returns 10, a value. So 10 will be displayed as output. Like this, you can practice with small programs. These are all with understanding. Here the program is not lengthy, but you should understand how the pre-processed directives are working. Okay, just now we have discussed about undef. Okay, first you define with pi. After that you define with undefined with pi. When you're trying to print out, it's showing error. Okay, it's showing error. It is not defined like this. You got the error. Fine. So like similarly how we did with the if definition macro. Okay, if you write if definition, the macro is defined, you will get the successful executing the code. Otherwise, else part will be executed if it is end with endif. Okay, so if definition followed by any macro you define, and with else part also you can define else and endif. So in case of generally we are using open braces, ending braces, and else we are writing if else statements. Okay, so in this example, we have defined no input is one macro. No input is one macro. Once it is, I'm storing a value 0. If and if no input, a equal to 2. Okay, I defined with something input. Else it will ask to reading the input value. Okay, and then it will print the value of a is so and so. Okay, fine. Now, these are all you can practice with pre-processed directives. And next, I will move ahead with the one important topic like okay, these are all various pre-processed directives you can practice. Now, another important topic is in end of the C programming, that is command line arguments. So, my dear students, please bear with 5 more minutes so that I can conclude with some more topics in C programming. Command line argument, that is the important topic. So Pavitra is using undefined. No, sometimes whenever you define, you don't want to use, then you can undefined. While you are using file pointer, file open, F open, right? If you don't want to use what you are doing, simply we are closing. Okay. If you are undefining, while if you undefine it, so that memory will not be released that memory. Okay. So again you can reuse that same constant with any other value or something. Okay, you defined a variable with constant variable. Okay, some memory will be occupied and you have fixed with some value. If you don't want, you can undefine it, so that the other people can access the same program. That means they can redefine it. Okay, that's it. Simply nothing is more than that. Is that fine, Pavitra? Earlier, by defining has defined, I kept pi value 3.14. Now, I don't want to define pi value as the 3.14. Undefined. With the help of undefined, I can undefine. After that, you try with printing, no value. There is no meaning of pi, right? You have undefined. That means pi is not recognized by the compiler. Okay, fine. And then what is that command line argument? Okay, so far we have executed the programs as GUI. We can also run the command programs in the command line argument, like command prompt. Okay, so the arguments passed from the command line are called command line arguments. These arguments are handled by the main function. So this is very, very important. So far I have not passed any arguments to the main function. I have not passed any arguments to the main function. Okay, you can pass some arguments to the main function also. Every main function internally, even though you are not passing, internally we have two arguments. One is called ARGC. One is ARGC and another one is ARGV. It's a pointer type and array variable. What does it mean? ARGC counts the number of arguments you are passing. By default, without using, my dear, main, so far int main without parenthesis, simply I'm using parenthesis, opening, closing. I have not used any arguments, right? But internally, there are two predefined arguments are available for the main function. What is that? ARGC and ARGV. ARGC will count the number of arguments. Okay, so it counts the file name as first argument, followed by any arguments, any parameters you are passing, that will be there. ARGV contains the total number of arguments. Okay, the first argument is the file name always. Okay, so the total number of argument 1, argument 2, like this. Let's see. See, if you observe this program, okay, if you observe this program main ARGC, ARGV, okay, if you want to print the argument, that is argument array starting with ARGV of 0, ARGV of 0, second argument ARGV of 1, ARGV of 2, and so on. The total count will be there in the variable ARGC. I'll tell you, okay. If the argument count is less than 2, that means what? It is 1. 1 means only program name. Then no argument passed to the command line, else first argument is so and so, it will be printed. That means what? I will tell you here the program. See, so far you are executing like this. You are executing the program like this. Okay, simply execute, compile and run. You are running. If you run the program through the command prompt, then you can understand. Assume that at EPROMPT, if you want to run this program, okay, so assume that your program name is test.c. This is your program, right? Okay, and in case of Linux, you should use like this ./test.c. Like this, you should run your program. But in this command prompt, your C program, I can use exe. One executable file will be created, followed by, assume for your program, you want to pass something arguments, like you want to pass 10, 20, 30 as an arguments. Sometimes you want to pass the names, something values, okay, ARG1, anything, ARG2, or sometimes you want to pass some names, okay, some name as a testing you want to pass. Otherwise, you want to pass some value 10, 20, 30 as an arguments. That means what? While running the program, you want to pass an arguments to the main function. Earlier, what we did it in case of int add of something I'm passing, right? Okay, int x comma int y. Okay, int y. Okay, return of add x plus y. We are passing, right? So for this function, we are passing argument within the main function we are passing. So for these variables, you want to pass through the command prompt to the main function itself. You can pass. That is also possible. Okay, that is also possible. While running the program itself, you want to pass. That is called through the command line. You can pass the arguments. That is command line argument. How can we pass? Okay, this is argument 0, argument 1, argument 2, argument 3. You want to print it? How can you print? ARGV of 0. If you say ARGV of 0, it returns test.exe. If you want to print ARGV of 1, what is ARGV? That is, for the main program, we have predefined argument variable. Okay, so that is ARGV of 0 in array of pointer, right? So internally, it takes every argument will be stored in that array. You can print it if you want, 10 like this. Okay, ARGV of 0, ARGV of 1, and so on. The count ARGC, it will give the total count 4 like that. Are you clear? So this is the ending topic, command line argument. Let us run this program. So you should understand how to run this command line argument. So let me complete this point. I'll minimize, I'll run the program. Command line argument. Yeah, I get somewhere command line argument. I already written something. I have somewhere this program so that I'll show you quickly. Maybe in the E drive. Yeah, command line in the E drive. I will open this file, open in the E drive, command line. See, for every file you should understand, for every file you see, okay, after compilation of your program, you see here for every file, okay, command line, see, there is exe file is created. So how do you understand this header file is C and exe? See, this is application. When you right click, go to properties, what is the file type? .exe. What is the file type? .exe. If you see here, what is the file type? .c. What is the file type? .c. Okay. So when you want to run this, that file should be there, .exe file. Then only you can run this. See, same program I written. Simply, I want to pass one single argument so that one example you can understand. Okay, main program in ARGC, ARGV. Program name. That means I want to print my program name as a first argument. This is predefined ARGV. Okay, ARGV of 0 gives your program name, and if you pass any argument, then it will print the argument also. Okay, fine. The first argument is it will print. If I give you only one thing, you will get no argument passed to the command line. You will get that message. Okay, fine. Where do you want to run this? Through the command prompt. That is the concept here. How can you open the command prompt? Simply, you can type CMD command. You will get the command prompt. Okay. So where is your file? In the E drive. Your file is E drive. Okay. So what is my file name? What is my file name in the E drive? What is my file name? CMD line. CMD line is my file name. CMD line.exe. Okay, followed by 10. I given something as an argument. See, what is your output? See, program name is CMD line.exe. First argument is 10. So do you understand? So ARGV of 0 is printed, ARGV of 1 is printed. Okay. If I run like this without argument, what is the output? Program name is cmd line.exe. No argument passed through command line. That is what we have written, right? If I'm not passing any argument count is less than 2. Okay. If you want, what you can do? You can print argument count also. Print %g ARGC. Then you will get the total argument count also. Okay. That you can test it. Okay. Thank you, my dear. These are the topics which we covered in the C programming. Hopefully next you may have other topics. Okay. Fine. Thank you very much. And till then, happy learning. And I'll share you. Today I have given some assignment topics in the files. Please try to do that files concepts. And I will share some more assignments. Okay. I will forward all the list of the assignments for files as well as other topics like preprocessor directives. Nothing will be there. And most of the things for the files concepts. Okay. Fine. Thank you. Thank you very much.
Thank you, sir. Thank you so much.
Yeah.